Hi friends, this is Arun. In this video, we'll have a look at graphs. So, what is a graph? Why we need a graph? Or how real world is connected with the graph in terms of computers? Okay. So, in real world, everything is connected. For example, right from our body to our friends to our family, everything is connected to each other. Even there is a theory which says that one end of the world is whatever happens affects the other end of the world. About the Babel, I think that's a movie which they explain that the butterfly effect, all those things. The same goes here. So in a graph, we try to represent all the connections in terms of nodes and connection vertices. Okay. So then what the node says is like the node is a representation of an element or you. Let's assume if it is a family, one node would be you, another would be your parents or your wife or your family, all those things. Okay, so ultimately graph is a collection of nodes or vertices or a vertex, okay, which is connected by edges or arcs. Okay, so each node contains an element, and the element could be a simple element by name. It could be your name, or it could be your whole property of objects. Okay, so either way it could be. So ultimately, we are trying to represent the real world in the things. Let's say, like I pick a table. The table has four legs, so those are connected, and the table has a tabletop, and it has a color. So all these things are connected. Okay. Even in this video which we are watching, so in this video we have an image and we have a text and we have a background color. Everything is connected. Okay. So let's assume I have a source code. Okay, so which includes another file, and that file uses some other file, and so like that the link rabbit hole goes on. Okay, so that is can also be represented with the graph. Okay, so this helps us to analyze the dependencies. Let's assume I want to install something, so this kind of graph is built at the back, and that would be helping us to find the dependencies. If you are in Linux, the package manager does this. If you are in Windows, the MSI does that, and every platform and every programming language has one way of representing this dependencies. Okay, so let's assume if you are a bank, so you can have this kind of connection, whether he has a credit card, he has an account, who has bought what, so whether he has the ability to buy other things. So all those things can be done. Fraud analytics you can do it, and the customer profiling you can do it by showing the this relationship. Let's assume if some in some area the people are buying diamonds, so it could be either fishy or the people are too rich. So by that way, like whoever is coming from there, we can show more of a richy ads. Okay, so and routes. Okay, so when I say routes, network routes, so shortest path to fetch a data. So that's what CDN does it. So the data could be from different sources, different paths. So whichever path is the best path, it picks it and starts doing it. Okay, like that it can go for it. So the application of graph is enormous, and it can be used for anything. So let's say like you are used to the driver cab hailing apps. Lot of apps are there. All the apps does that. So which area, which driver is there, and all those guys are connected and kept it. Whenever you send a request, it picks a note from that and starts giving you to the list. Okay, as simple as that. Okay, so that is one way of the. Another thing is Google Maps. So your simple Google Maps does the same thing. Every city is represented by a node, and every route is represented by a vertex or a edge. Okay, so connecting flights from one city to another, and highway connection cost. What is the shortest path from travel to here and there? And what is the number of connections which I need to make in a computer chip, and more or less the garbage collection. Let's assume the modern languages like Java, Python, all these guys are having a automatic garbage collector, C sharp. Okay, so how they do is they link the connected objects, and whenever there is a function is over, the link has got broken, and whoever is orphaned, they get killed. Okay, and typically represent your family histories. Similarity testing, this is a big popular usage. It's a dating service. Let's assume you are building a dating service. That I think Mark Zuckerberg built the similar thing when he was doing the first project or second project, I don't know what's number. So it'll help hot or not kind of thing. You will be able to match this and then do it. And playing dynamics, like for example any playing game like football, cricket, the match analysis is done this. and even you can do a self-analysis based on your attributes and your actions. All those things can be represented in a graph, and when the graph is given to a system and it processes in a better way. So in the graph, we have two types of graph: directed and undirected. Okay, the directed graph is like kind of a one-way path, whereas undirected is a two-way path. Okay, so the directed is always having an arrow which way you should go, kind of it. So what is the next sequence of steps? All those things would be clearly stated. A flowchart is a directed graph, whereas undirected is like a connected with weightage. That's all. Okay, it could be both the ways. So it could be here they haven't mentioned any direction at all. Okay, so this is undirected graphs, and a directed graph is also called as a digraph. So I mean, shorter version, nothing big about it. Okay, so these are the two common graphs, and the cyclic graph has at least one cycle. For example, in this case, Delhi, Chennai, and Madurai is a cyclic graph. A cyclic graph is like a graph that doesn't have any cycles at all. In real life, there is no acyclic graph. Most of things are cyclic graphs. And graph terminology. What are the terminologies that we need to go for it? So one is size of the nodes, the number of nodes, or the number of balloons which you have. And you can have a zero size nodes graph, that is called a empty graph, and neighbors or the adjacents is one straightforward. Degree, okay, so degree is number of connection it has. Let's assume Chennai is connected to three kind of states and its degree is 3. So in degree and out degree is like when it comes for a digraph, it comes in like when you have an arrow mark. So it's a one way or a two way kind of it. uh, Now comes the biggest thing: trees versus graphs. So trees also has edges. That's called left node, right node, all those things. It has the edges. So what the heck? How it is different from a graph? Whether it's a graph and tree are same? Okay. So the simple answer is the trees are special case of graphs. Trees is also a graph, but it is a special case. That's all it is. Okay. So it is a acyclic graph. A tree is a acyclic graph because there is no cycle. Okay. Probably your family tree you can represent as a acyclic graph, which is a tree. You can call it. And either you can it has the same kind of left and right, all those nodes, and it is directed in a way, a directed graph. So this is a simple way of representing a graph class. So we'll look into the other complexities in the next videos. Okay, thank you friends, bye bye.